Lesson 21 is called multiplying powers, and when we're talking about powers, what we're really talking about is a combination of a number that's a base and also a number that's an exponent. So for example, here the base is the big number is a, and the exponent's 3, and the base is being taken to the third power. Now the combination of the whole thing is called a power. And what we're talking about in this lesson is when we multiply powers. So for example, if I have a cubed times a to the fourth. Now there's two different ways we could do this, but one way is more of a shortcut than the other. Now let's talk a little bit about how we get to this shortcut. Now a cubed, what's this mean? It means a is going to be taken times itself 3 times, because it has an exponent of 3. Now we're multiplying whatever a cubed is, which is a times a times a to the fourth, which would be 4 of those a's. Now what I have here then is the multiplication of 1, 2, 3, 4, 5, 6, 7 a's, or in other words, a to the 7th. Now one way I could have gotten this rather than writing it out like this is simply to add the exponents. If I add the exponents, I get that 7. Now another example would be, I'm going to put this down in the bottom left corner, is if I had c to the second power times c to the fourth power. Now if I wrote this all out, I would have c times c, 2 of them, times 4 more of them. So 1, 2, 3, 4. Now what I have then is c to the 6th power. I've done what we call simplifying this expression. So the rule for multiplying two powers, is that you add the exponents. So 4 plus 2, I get c to the 6th. Up here, when I multiply two powers, to simplify this, I add the exponents, and that would be a to the 7th. Now let's take a look at example 1, and it says simplify this expression. Now what I have here is an expression that has all multiplication. So in other words, when I have x right next to the y, that means x times y times x to the fourth times x cubed times y to the fifth. So for example, in the first part of it, I don't need to write a or x raised dot y. I can just write it xy, meaning x times y. Now we need to simplify this expression. Now before we simplify the expression, let's take a look at all the exponents. Notice the first two do not have an exponent, but really there is one. When there's not an exponent, it really means it's to the first power. So what I have here is x to the first times y to the first, and so on. Now what I'm going to do here is when you multiply numbers, does it matter the order we multiply them? So for example, if I have 2 times 3, is that the same thing as 3 times 2? And the answer is yes. So it doesn't matter the order that I multiply them. So what I'm going to do up in example 1 is I'm going to change the order around. So I'm going to put all my x's together. So I have x to the first, I have an x to the fourth, I have an x cubed, and then I'm going to put all my y's together. Y to the first and y to the fifth. Now, how do you multiply powers? Now, something that I want to emphasize that I didn't emphasize on the previous slide is if I have a squared times a to the 7th, if I'm going to use this rule where I add the exponents, meaning that this is really a to the 9th, I have to have the same base. It doesn't work if I would have had a squared times b to the 7th. I can't just add the exponents and get something like ab to the 9th. That doesn't work. I can't simplify that. But I can simplify it if I have the same basis. Now over here I have the same base of x. So this is simply x to what? Well, I add the exponents. 1 plus 4 plus 3. And I have x to the 8th. Now that should make sense, because if I wrote this all out, let's see, x, one of them, times 4 more of them, 1, 2, 3, 4, and then 3 more of them, you kind of get the idea. I'm going to have 8 of them, or x to the 8th. Now how many y's do I have? Well, multiply the powers. So when you multiply the powers, you add the exponents. So 5 plus 1, I have 6 of them. So I've simplified this, and my answer is x to the 8th, y to the 6th. In example 2, let's do the same thing as what we did before. Let's simplify this expression. And again, notice it's all multiplication. And notice what all my exponents are. So here, this is an x to the first, this is an m to the first, this is m to the first. Now I want to really emphasize that if I wrote this out, I'd have x cubed times x to the first times y squared times y to the 5th times x to the 7th times m to the first times m to the first. So really I have individual powers, but I don't need the raised dots because we know that it means multiplication. Now let's simplify this expression, and notice that I'm going to place all my x's together. So I have an x cubed times an x to the first times an x to the 7th. Now I'm going to put all my y's together. Y squared, y to the 5th, and then m to the first, m to the first. Now combine these, and combine these. So with my x's, when you multiply powers, you add the exponents. So I have 3 plus 1 is 4, 4 and 7 is 11 of them. And that should make sense, right? Because x cubed means x times x times x times another x times 7 more x's. I'd have 11 x's times y to the 7th, and finally m squared. And that's my simplified expression. Okay, example 3 is a little change of pace. Now, in this expression, are we multiplying everything? So in other words, if I went back to example 2, notice everything was multiplication, but here I'm actually adding things. I'm adding and subtracting things. Now remember what we've said when you add and subtract things. Things that are connected by plus and minus signs are called terms. So I have one term, second term, third term, fourth term. Now what is the only way that you can combine terms? And if you remember back to lesson 19, the only way you can combine terms is if they're like terms. Now notice this one here, that's an x squared y cubed. This term is an x squared y cubed. They're the same. This term is an xy. This term is an xy. So in other words, like terms are the same combination of letters. And notice what I've underlined are the same combination of letters. Now let's take a look at this one right here. Remember, there's really a 1 in front of it. Now let's combine like terms. Now let's do the one-liners first. Look at the sign in front. So is this 2, is the 2 right here positive or negative? Is this 2 right there positive or negative? There's not a negative sign in front of it, so it's positive. That's a positive 2. So I have 2 minus, again, looking at the sign right in front, 2 minus 8. And let's see, 2 take away 8 would be a negative 6. All right? So I have a negative 6 of those x squared y cubes. I do nothing with exponents because all I'm doing here is adding and subtracting like terms. Now let's do the two-liners. So I have 1 positive, 1 minus 5, which is a negative 4 of the xy's. And I'm done. I've simplified this. Now if I would have done the two-liners first, I'd have a negative 4 xy minus 6 x squared y cubed. Both these answers are identical. They're the same answer. Either one is as correct as the other one. Alright, last example is example 4, and the same thing. We're going to simplify this expression. Now again, we're adding and subtracting terms. Now are any of these like terms? So I have an x to the 6y. This is an x to the 6y. Is the last one an x to the 6y? No, it's y to the 6. So in other words, notice that the first two are like terms because both of them, x is being taken to the 6th power and then y. Now I have just an xy, And then finally, I have a x y to the 6. So I actually have 3 different types of terms. Now I'm going to combine the one-liners first. Then I only have one-liner. I just have 3xy. Now I'm going to do the two-liners. What number's right in front here? A 1. What number's right in front here? A 1. So look at the sign in front. Is it a positive 1 in front of each of them, or is it a negative 1? Well, there's not a negative sign or a minus sign, so they're positive. So I have 1 plus 1, so I have 2. I have 2 of them. Positive plus 2 of those x to the 6 y's. Now finally I have the 3-liner, which is a minus 5x y to the 6, and I'm done. Now another way I could have written this, and again notice that I did not do anything with the exponents. The only time you do something with the exponents is when you're multiplying powers. So if I had x squared times x to the 4th, that's x to the 6. That's where you add the exponents. Down here, I do nothing with the exponents. All I do is combine like terms. The exponents stay the same. Now if I would have combined the like terms differently, so for example, say I did the 3-liner first, I would have had a negative 5x y to the 6, and then maybe a plus 2x to the 6y, and then my positive or plus 3xy. So there's different orders that I could have had here. So the topic in this lesson was multiplying powers, and when you multiply powers you add the exponents.